Okay, welcome back. So here we're going to be going over some more rules of derivatives that we should become familiar with because we're going to be using them quite a lot in our problems that have to deal with derivatives and applications. So there's one rule that's called the constant multiple rule, where if C is a constant and F is differentiable, then the derivative of some type of function with the constant attached to it would be such that the C would stay unchanged, and it's just times the derivative of f of x. So what I would say here is like C stays the same when deriving. Okay. So let's check out an example like this. So f of x equals 1/5 x squared. So I want to take the derivative of this, right? So in the situation, this 1/5 is your C where it's going to be unchanged, right? It stays the same. So what we're really going to do is just take the derivative of this x squared right here. So what this becomes, f prime of x, is that 1/5 stays the same, but I'm taking the derivative of that x squared. So once again, derivative, the 2 drops down, right? And you subtract 1. So what this f prime of x becomes is times 2x to the 1, right? And what that really is just 1/5 times 2x, which is just 2/5 x. And that's your answer. Okay. So the constant becomes unchanged when you take the derivative, right? We took the derivative and it's still 1/5. Okay. So just a couple intuitive rules like sum and difference rules. And this just means that, I'll go over it, but, you know, if you have some f of x or f and g that are both differentiable, and if you take the derivative of the whole thing, what you really can do is just take the derivative of them separately, right? You could just individually take the derivative of each of them. Likewise, for the difference rule, you're subtracting, you can just take the derivative of them individually while subtracting. So what this rule do, it just means that you can take the derivatives individually. Okay, so let's check out an example. So this one says dy over dx. Once again, this just means like, y prime, the derivative, right? So we just have a couple terms here of a 7x cubed, 12x squared, 5x minus 10. So this is like a combination of sum and difference rules. But what it means is that we can just take the derivative of each one of these components separately and get the answer. So let's go ahead and do that. So y prime would be 7 times 3x squared minus 12 times 2x plus 5 minus 0. Right? So kind of go over that again. Right? This 3 drops down, we subtract 1. This 2 drops down, we subtract 1. Derivative of this guy right here, right? We just drop the x. And then derivative of a constant just becomes 0. Okay, so just putting a bunch of these rules and properties together. And we just simplify a little bit. So this becomes 21x squared minus 24x plus 5. And that's my derivative. Okay, great. So let's go ahead and look on to example 4. So if f of x equals 3x squared minus 2x plus 4, we want to find and interpret the meaning of the following. Okay, so f of 2. So this one's some we should know already where we just plug in 2. So we're just going to plug in x equals 2. So this equals 3 times 2 squared minus 2 times 2 plus 4. And so this becomes 3 times 4 minus 4 plus 4 which equals 12 minus 4 plus 4, which is just 12. Okay, so what does this mean? So this means that the function is 12 when x equals 2, right? Input, output, we get the point 2 comma 12, right? So we're a little familiar with that one. So now what about this next part B, where it's asking us, or well, f prime of 2, right? That's how we kind of say that. F prime of 2. F prime of 2. What does that mean? So first thing we got to do is find the derivative of this, right? So you got to find the derivative of this guy. So first thing we do, derivative. F prime of x, or you know what, let me write out f of x. F of x equals 3x squared minus 2x plus 4. And we got to find the derivative. So f prime of x, right? Here's an arrow just to note that we're taking the derivative. And, when we take a derivative, right, it's 3 times 2x minus 2 plus 0, right? Just to reiterate, the 2 drops down, we subtract 1. The x drops when it's just an x, and then the constant just goes to 0. Okay, so simplifying this out, we get 6x minus 2. Okay, so that's the derivative. All right, but we're not asked just a derivative, we're being asked the derivative at x equals 2, f prime of 2. So we're going to plug in x equals 2, right? So if I plug in x equals 2 into the derivative, so f prime of 2 equals 6 times 2 minus 2, and that is just 12 minus 2. All right, so we get 12 minus 2, and that just equals 10. Okay, so what does this mean though, right? So remember when we talk about derivatives, it's synonymous with, tangent line and instantaneous rate of change, right? So what this f prime of 2 really symbolizes is the slope of the tangent line is 10 at x equals 2. Okay? Or the instantaneous rate of change at x equals 2 is 10. So we're pretty much saying the same thing all around, but it's just the slope of the tangent line at x equals 2, the instantaneous rate of change at x equals 2, and that's just going to be 10. All right, so that's how you do that one. And got a couple more. Right, so that's it for this video. We'll see you next time. Thank you. Bye.